All right, just by the show of hands, how many of you have attempted the homework, the one that I've put it up here? And if there were any problems with it, so we can quickly go through it as well, especially where the problems were, before we continue to the next part of the lesson. First, by show of hands, how many of you have attempted it? And then if there was a problem somewhere, maybe it was not easy to explain, then I can maybe start with the problems and then we can quickly rush through the rest of the things just to compare answers and make sure we understand the part that we had to basically complete. Any problems on the homework, the one that you see in front? Some questions maybe you did not understand, and then I can start there and then we can continue with the rest of the lesson planned for today. Or we haven't attempted to do this one. Not hearing anybody saying anything. So I'm waiting for an answer. Like if you have done the homework, if you have done the homework that you see the basic operations, and if there was any problems or it was easy, or maybe we did not do it, and then at least that way I know where we are. It means I have to go through it as well. Marshally, hand is up. Is there, did you do it, or there's a problem area that I need to explain, something like that? Marshally. Okay, apart from Marshally, okay, I see on, let me just show you guys what I'm also looking at so that you can see. So I see on the Google Classroom, only 2 people attempted it, Osha and Loide. And Osha, there was no attachments, but with Loide, I could see there's attachments over there. And this is basically also how it shows if you do something, then I can immediately see what it is that you have done. And as you can see, it's a PDF. So thank you, Loida, for attempting, and we can immediately see what is going on here. So Marshally, the hand is still up. Okay, Marshally just attempted the first few, and then Loida is requesting an explanation on number 19 and 20. And that is basically what we wanted to do. So you have to attempt the questions to get a feel for matrices. This is not something that we have done before. It's not like normal algebra things or anything like that. This is like a totally different topic, a different exercise, and different calculations and things that we have to do. So if you do not attempt it or try it out, you will not know what is going on. The brain will not have created that memory bank to say, oh, matrices, we have to do this or something like that. So it will be very difficult going forward. And as I've said before, that it's only going to get difficult. And so if you don't try those basic exercises, it will just keep getting difficult and difficult. And later on, you will feel like this things is just not for you. So we still have a lot of people not attempting or trying. So please go ahead and try it out as well. I will be, however, explaining the two questions from Loida, because she said number 19 and 20. So that is where I will start. And then, yeah, for the rest, if I don't have anything to see, then it's difficult for me to know where you are struggling and where I can help you. So I'm just here to help you. But if there is nothing from your side, then I also don't know where to help you specifically with where you are struggling. Okay, so I will just shift down to 19 and 20, which is over here, and try to explain this to Loida. And as you can see, it's, as I said before, this is not like normal things that we have done before. So it will be a little bit tricky, and you have to practice. You have to go through the basics on top to be able to solve some questions like this later on as well. All right, so this is the only one I will be doing now, and then I will leave the rest for the rest of you guys to go and attempt. And for Loida, who has completed it, I will mark that one and then return your marks to you, hopefully by the end of today. And that is basically where we are. So let's just quickly get into this. So over here, it's basically we have to add. And before we even add, the first thing we have to do is to check the order or dimensions of the matrix. So in this case, it's important to note that where you have a term and another term, these are two terms. When there's two terms, this forms like one number as it on its own. So this is like one number, it's on its own, and then the rest goes the same. So over here we have a 3 by 1, because everything here is just one column, and then I have 1, 2, 3 rows. So that's important to note on the left hand side, and then on the right hand side I also have a 3 by 1. That's the first thing you have to do with matrices, is we have to check dimensions. And in order for us to add or subtract matrices, the dimensions must be the same. Okay, so this 3 by 1 is equals to the 3 by 1. It's the same. The rows are the same, the columns are the same. So this I can definitely add. Okay, so that's the first part that we need to always do. So I'm just going to write 3 by 1 on top, just to use the space at the bottom to do my calculations. Okay, and so I'm also showing you how to solve this matrices that you will come across. You have to first check the dimension. And as I said before, matrices is basically the topic that will determine if you are lazy, you will not understand anything, you will not do anything, you will not get any marks on this. And because it requires you to work. If you don't work, then nothing will happen. It will just look crazy to you. So once we have this dimensions correct, I want to use, okay, I don't have gray, but let me use black. I want to now just draw a line here. This line will just show me that this is the things that I have to add together. So I have to add this with this. Okay, so that's what the line is for. So I normally do this with a pencil so that I don't get confused as to where to add and so forth. So adding and subtracting is just like what this element over here with the corresponding element on the other side, and the same for all of them. So for the first one, I will put in a bracket, everything that is there. So I have a minus 6R plus T, and then we plus it again with another 6R. That is what I need in the first row. And then in the second row, I'm just going to use another bracket, minus R plus minus 40. And remember, when there is a minus, plus minus things, I always put the minus in a bracket. Okay, and then the last one, I have 6S This is also in a bracket. And then this is plus minus 3r plus 2. So basically, we are just simplifying, and this is all going to be in one matrix. That is how it is. So now I'm just going to simplify everything. So minus 6r plus 6r is 0. Okay. So the 6r here. Do we have to put the brackets? Yeah, we are dealing with matrices here. So everything was supposed to be in that bracket form. So I just wrote it out, and then this square bracket is what determines a matrix. Okay. And now I'm just going to simplify the things inside so that it looks neat as well. So I'm looking at this minus 6r, the grouping the like terms, plus 6r. Okay, that is the like term. So those two will cancel each other out and make a 0. So 0 plus t will only be t for the first row. Okay. And then for the second row, I have minus r plus minus 4t. So that will just be minus r. And remember, the positive and the bracket negative makes a negative. So it will be minus 4t. That is the only answer we have there. And the other one, since this is 6s minus 3r plus 2, so these are all different terms. Okay, now none of them are like terms. So then I will just remain with that. 6s plus, and remember again, I forgot to put the bracket for that one. There is a bracket here because it's plus bracket minus, which will result in a negative. Okay, so it is 6s minus 3r plus 2, and that is your final answer here. So again, as we've said, this is just testing your ability to add and then follow algebra rules. All the other rules you've learned before, you just have to follow them again inside here. And that's basically what we have to do. And the same thing goes for the other one. Now I'm going to be doing it a little bit faster because I know now I'm just adding things. So I can already see that this, all of them in the first row. Let me just draw the line there so that you can see. I forgot to put out the dimensions as well. So this is a 4 by 1. This is also a 4 by 1. So I can definitely add them up. So the first one, I see all of them are unlike terms, so I will remain with unlike terms. So it will be z minus 5 minus 3y. They are all unlike terms. I'm now not doing this extra thing of the brackets inside here. I'm just finish adding up immediately. Okay. And then minus 6 plus 3z, that will be minus 6 plus 3z. Still unlike terms. There are no like terms for me to simplify. But on this one over here, on the third row, I have a 1 and I have a 5, and I have a minus 6 and I have a z. So there are two like terms. Numbers and numbers are like terms, and 6z and 1z are also like terms. So I have to now add the numbers to the numbers and add the algebra expressions to the algebra expressions. So for that one, I will just change the color quickly. Minus 1 plus 5 is 4. Okay, so the 4 comes from the minus 1 and the 5. Okay, minus 6z plus z will give me minus 5z. Okay, so the minus 5z is coming from the minus 6z with the minus and the plus z. So it's a 1z. Okay, so that is the addition sign is still here on in between the two. So that is what I'm doing. And then the 3y plus the 4z, those are all unlike terms. So I will end up with a 3y plus a 4z. So here, and then finally, once I've written down all of them like that, then I can now close off with my square brackets, and that is basically how our matrix should look like. So the matrix over here is still going to be a 4 by 1, 4 rows, 1, 2, 3, 4, and 1 column. Although there are different terms inside there, they each form one placeholder of a number that we have. And those are the 2 questions from Lloyd. I hope I've answered those questions. And the rest, as I said, I will not be doing corrections. I will only do corrections if you guys attempt it and tell me, no, sir, I have a problem with this, then I will explain it. Because if I just explain everything myself, it's not me who needs to understand them, it's you guys. So it will be a little bit of a problem just to give answers. That's what textbooks are there for. But these topics, as I said, in most of the textbooks that we have, except for the new ones, they are not there. So we have to practice. All the practice questions that I'm putting up here are for you guys to basically understand what we need to do. All right. So with that said, I will proceed to today's topic. We are still on matrices, and we will continue explaining them as we have before. All right. Is there any questions before I start, so that at least I know I can proceed? If you have any questions. I don't know what the hand clapping means. Okay. All right. So as you have seen before, I'm just going to be indicating to you what we have done so far. Represent information in matrix form. So we know now matrix form, how it looks like. Calculate the product of a scalar quantity and the matrix. We have done that. Scalar multiplication, it's from the activities before as well, if you have to practice. Solve problem involving the calculation of the matrix. That's where we are left. We did the sum and the difference. This is addition and subtraction of matrices, not exceeding a 3 by 3 matrix. So you would have seen most of our matrices are not exceeding 3 by 3. So by saying not exceeding 3 by 3, it means you won't have a 4 by 4. Okay, so 4 by 4 is a little bit heavier, but a 4 by 1 is smaller than this one, right? So remember we said if you want to know the dimension, the size, we just multiply 4 times 1, then you see it's just 4 elements in here, but this one has 9 elements in there. So basically this exceeding just means the number of elements that we have to look at, okay? So if it's less than 9, then it's okay, all right? So we have done that as well. And then today we are going to look at the product of a matrix not exceeding 2 by 2, all right? And by not exceeding 2 by 2, we are trying to explain that when we are calculating, most of the time, we will limit it to this. But for the examples that I have, it may even sometimes go to 3 by 3, but the calculations are a little bit more longer than a 2 by 2. So the sizes here is just based on how much do you have to calculate to get the answers. And that's basically what we will be focusing on today. And we will be mentioning some of these things as well. Hopefully, I hope by explanations, we will also get to do the zero matrix and identity matrix. If time permits. And then the other two we will be doing separate lessons for Wednesday, sorry, for Tuesday first. This one we want to do on Tuesday if we manage to finish the zero matrix. So that will be Tuesday, and the last one will be on Wednesday. Okay, so that's basically what we want to achieve for the week. And then we will be having a test online to see if you understand these things as well. Okay, so let's proceed. Let's see if I can go to the slides directly. So we looked at matrix addition, let's explain that. And we also looked at equal matrices. Okay, and today we are going to look at matrix multiplication. All right, so I am going to be very slow with matrix multiplication because there's things we need to understand and before we continue. And as I said before, that it's a different topic. It's not the same as your normal calculation things. There are certain new rules we have to apply, new rules we have to follow. And this is why I'm taking a very slow approach to this, okay? So here's the first rules. We can multiply two matrices A and B together and write C equals AB. So this is just a normal algebra expression. We can assign a new matrix, okay, from multiplying two different matrices together, okay? So that is basically what it means. So we can either call it AB or we can call it C. Doesn't matter which way we do. So how do we multiply matrices? Okay, we can only multiply matrices if the number of columns in A, okay, I will underline certain keywords now so that we can see number of columns of A, okay, is equal to, right, and equal to, I have a highlighter. Let's see, it says here spotlight. Let's see what the spotlight means. But spotlight doesn't want to do anything. But I could highlight certain keywords. Okay. So number of matrix, number of columns in A equals number of rows in B. All right. That is very important. Now, let's first talk about what this means. Now, beforehand, before I explain this, we know to add and subtract a matrix, we said that the number of rows and number of columns must be the same for both matrices, then we can add them. But for multiplication, the number of columns of the first matrix must be equal to the number of rows for the second matrix, okay? If A has a dimension M by N and B has a dimension N by K, then the resulting matrix C will have a dimension MK. Okay, let's break down this. Okay, so let's say we have a matrix A, okay, which has a dimension of 3 by 2. Okay, and then we have matrix B, which has a dimension of 2 by 4. Okay, now in order for this, let's also have another matrix. Let's say we have a matrix C, which has a matrix C, which has a dimension of 3 by 2 or 3 by 4, 3 by 2, 3 by 2. And another matrix D, which has a dimension of 3 by 4. So in this case over here, we want to look at which one of these matrices can we multiply together. So we will check, can we have AB? Okay, so AB, that is a question mark. Can we have, I'm now just using A to see which one we can multiply. AC, that will also be a question mark. And can we have AD? That will also be a question mark. So we are looking at if we can multiply A with B, A with C, A with D, okay? If we can multiply the two matrices like that. So what is important for us to note is the row and the columns for each one of them. All right. So for the first one, A, we know that the 3 here, I have to use another color, green. The 3 here is the row, the 2 is the column. Here, the 2 here is the row, the 4 is the column. Over here, the 3 is the row, the 2 is the column, and over here, the 3 is the row, the 4 is the column. Okay, so the rule over here says the number of columns of the first matrix, okay, we just say of A, because A is the first matrix, must equals to the number of rows of the second matrix. In this case, the second matrix is B. Okay, so for us, all our first matrices is A. That's the first matrix. So here you must now look at the number of columns of the first matrix. So the columns for the first matrix is a 2 for A. It will be a 2 here also, and it will be a 2 here because 2 is over here. 2 is the number of columns. Okay, and this must be equals to, let me just make the equals to sign correct. This must be equals to the rows of the second matrix. So the second matrix here is the B. The second matrix for this one is the C, and the second matrix for the other one is a D. So B, what is the rows of B? So B has how many rows? 2. So B is equals to 2. Okay. C has how many rows? 3. C has 3, and D has how many rows? 3. So D has 3. So if we now evaluate this and say, can we multiply AB? Since 2 equals to 2, yes, we can multiply AB. This can be multiplied. Is 2 equals to 3? No. This one is no. So this we cannot multiply. Is 2 equals to 3? No. So we cannot multiply. So this is now one of the first rules that we have to look at over here. Now this rule is different. I say again, it is different from the addition and the subtraction. Okay, so if we look at addition and subtraction, we could see that A, matrix A, if I which color do I use this? Matrix A over here, which is a 3 by 2, and matrix C over here, which is also a 3 by 2, we can add them together. Okay, we can add them together because their dimensions are the same. That is for addition. All right, but we cannot multiply them together because the column of A is not equals to the row of C. So this brings up a new rule. Matrices that can be added or subtracted together can therefore not be multiplied. Okay, I hope that makes a good observation for us to notice as well. So matrices that can be added together or subtracted cannot be multiplied together. Now, this is why I said these rules and things are confusing, and if you do not practice the questions, I will just be talking another language. And unfortunately, I cannot practice for you. You have to practice these things out so that you can see the moment you write something down, it becomes stored in your memory for permanently, and then you will be able to see that, okay, these two matrices can be multiplied together, or we can not be multiplied together. So this was just a short demonstration, okay, of what we expect you to understand and to do. And normally we will be not giving you this form, we will give you the matrices themselves. And then you have to now determine what is the dimension of that matrix, of all of the different matrices, and then see if you can answer the questions at the bottom. That is basically what the basic activity was also trying to test you. Can you add certain things? Can you not? You have to see it yourself. And that way you will be understanding it much, much better. All right. So then there's this part over here that explains that if we have a matrix that can be multiplied. So we've noticed that in our examples where A equals to 3 by 2, and B equals to, we said 2 by, I don't know what it is, 4, for example. And we notice that the column of A, which is 2, this is your column, this is your row, this is your row, this is your column, is equal to the row of B. So we notice that since this and this are 2 and 2, they are equal, all right? Then it says that our n over here is equals to the n over there. That's why the n's are the same, okay? So the 2 and the 2 are the same. Then it says our answer for A times B, okay? So this means we can have A times B, okay? So our answer for A times B will now have a dimension of this 3 will come down. It will be a 3 by 4. Okay, so our answer will be a 3 by 4. So you can see how they use the dimension of the matrix for multiplication. The 2 and the 2, the column here and the row here are equal, and then our answer will be the row of the first matrix and the column of the second matrix. That's how the answer will look like. So this is a very important step and observation as well that you will have to see. So you can see that 3 by 4 is not the same as a 3 by 2, and it's not the same as a 2 by 4. Okay, it's a totally different matrix because of the dimensions are different. But we have noticed that in addition and subtraction, that the matrix will stay the same. The dimension of the matrix will stay the same. But in multiplication, the dimension will always change. Okay, now this is just the way I represented it. I wrote it down. However, there is one exception when we have equal matrices. So for example, if we have a 2 by 2 matrix, and let's say this is D, okay, and we have E, which is also a 2 by 2 matrix, then you will notice that this is your row, this is your column. This is your row, this is your column. You will notice that the column of the first D and the row of E are both 2 and 2. So 2 and 2, this is coming from that, this is coming from that. We can therefore multiply a 2 by 2 matrix with another 2 by 2 matrix because the columns and the rows are the same. And then you will notice that our answer will have also a 2 by 2 because the row of the first matrix is 2 and the column of the second matrix is 2. So if your matrix are equal matrices in terms of the dimension, right? Equal matrices means or not equal matrices, square matrices, right? The square matrices over here, okay? Because they are equal matrices. D is equal to E in terms of the dimension, but we don't know the elements, right? But they are both square matrices, equal number of rows, equal number of columns. If this was a 3 by 3, then we will not be able to multiply it, okay? So the result here for the 2 by 2 square matrices, if we multiply 2 by 2 square matrix with another 2 by 2 square matrix, we will get a 2 by 2 answer. That is the only exception for multiplication that we have. If it's a 3 by 3 and a 3 by 3, we will get a 3 by 3 at the end. So I'm just following these rules that we have over here. And that is basically the first explanation that we have. So the result of your rows of the first matrix, the column of your second matrix will be your new matrix dimension, the answer after you get your multiplication. Also note that in matrices, we have two multiplications, right? We have a scalar multiplication. That's now when the scalar is the number outside of the brackets. Let's say we have 1 and 2 over here, and this will result in our 3 and 6, okay? That is a scalar multiplication. And then we have a second multiplication where we are multiplying a whole matrix by another whole matrix, okay? And this is also what sometimes is confusing to some of the learners, to remember that there's two multiplications with matrices, and which multiplication, when do we use which one, and so forth, and how to apply them as well. Okay, so we cannot multiply equal matrices except for equal square matrices. That's the example I gave. That was the exception. Okay. And here we have examples again, different matrices over here. And for this one, I would really like you guys to unmute your mics and also please participate, because it's supposed to be a say out loud exercise that we have here. So based on these dimensions that we have here, can somebody just say for the first one, can we multiply AB? Can we multiply BC? Can we multiply CD, DE, AE? Just a yes or no would be sufficient. So please unmute. We just want a yes or no, and you say matrix A times B, no or yes, and then I'll just write down here, and then we can check the answers together. This is a very important activity, so participation here will allow us to understand the next parts very, very easily. Okay, the floor is open for anybody to start.
A times B, no.
Okay, so I have a no from Rishua. Okay, I'll just keep in mind who said it there. Thank you. Next person.
BC, yes.
Okay, I have a yes from Napu. What do I say? Napumwe, or do I just say Napu? Come on, guys. We don't have a lot of time.
C times D, yes.
Okay, Felicia. Next person. It looked like we went in order. So Jay, Marshally, Loida, Giovanni, Liesel. I don't know who's Fluffy Mellows. We are waiting for answers. Any D times E, A times E. Please, guys.
D plus E times E is no.
Okay, that's from Loida. Last one.
A, yes.
Okay, Napa is saying yes.
E.
Napu. Okay, guys, we have about seconds left. So I would suggest we reconnect. I just took a snapshot of that. So let us just reconnect.